Hey everyone, John here, senior software engineer with over 10 years of experience. I'm the lead maintainer of Latterly.io, an open source educational platform that will help you land your first or next programming role. You can sign up for free and join the Discord. If I don't get to your questions today, or if you're viewing this stream at a later date, you can always drop by and drop your questions over there. Today, we are in part 4 of a LEETCODE Marathon. And this is going to be a short session because I have a call in like 45 minutes. So we'll be looking at under 40 minutes here. I'm working on this 1197 minimum night moves, and the motivation for this is interesting. And I may be adding this to the LeetCode kata. So this problem uses an infinite chessboard. And the thing that's interesting about an infinite tree or an infinite board is that DFS doesn't work. DFS doesn't work in an infinite board. So you need to use BFS. And this is interesting because I was using interviewing.io and I had a preparation, like coaching call. And one of the questions I asked the guy is it true that you can basically interchange BFS and DFS so that pretty much any problem BFS solves and vice versa? It's a matter of preference in which one you're comfortable implementing. And he was like, no, like infinite board problems, BFS can be used to solve, but DFS can't. And so that seems to be a gap in the kata. And this is a problem that he recommended. So I've never run this problem before, but let's take a look at it. But I'm approaching this problem and I have in mind that I'm going to be doing BFS. And that's basically the only thing I have going for me. That and that I know how knights move in chess. Okay, so I think that lays the groundwork, what we're doing and why. Seimu says, what are you building today? We're practicing LeetCode, the problem in front of us. I think that lays the groundwork for what we're doing and why, as well as the expected timeline for this stream. So we'll work on this for up to 15 or 20 minutes and time box that and look at the solution if needed. Okay, so let's read the prompt together. An infinite chessboard with coordinates from negative to positive infinity. You have a knight that starts at 0, 0. It has 8 moves that it can make. Each move is 2 squares in one direction and then 1 square in an orthogonal direction. Return the minimum number of steps needed to move the knight to the square xy, and we are guaranteed that an answer exists. So I guess there could be some squares that might never be reached, and we are basically guarded against those. One moment, my daughter is calling me. Okay. So, are you looking for work or doing this for content? Both. So this is part of my FANG interview preparation. I have a FANG loop coming up. Actually, I have 2 tier 1 loops coming up. So hopefully this helps, but then also, yeah, also content, right? Let's see. So in example 2, the input is 5, 5. That's really interesting. 0, 2, 1. So how do I know to go that direction? I just failed Amazon. That's okay. You can give it another shot. What is it? Did you get a cooldown? Maybe a 6-month cooldown? Give it another shot later this year. So how do I know that I even want to head in that direction? Okay, I can get closer and closer, right? I know that I want to like move up and to the right. Like moving down and to the left will not take me closer to 5, 5. Some of the community comments were filtered. What are y'all saying over there? Be nice. They said I can apply right away. Cool. All right, well, keep us in the loop if you end up doing that. Do you study low-level design? Maybe. Are you talking about like API design? The problem with low-level design is that I don't know what the person is referring to, but I've done design at all levels. What laptop do you recommend for a freshman majoring in CS? You can check out the Latterly blog. The hardware required is article number 6. Check out article number 6. Okay, so I can figure out my directions from here. And maybe that I can use a process of elimination to figure out moves that won't help. I don't know that that will always work, but it seems like a direction to go. Come on, noob, get on with the code. No, you don't want to start coding if you don't know what you're going to code. That would be ridiculous, right? So I'm actually not sure that this solution is even going to work, but we'll give it a try. So intuition, list moves, then use a process of elimination. We can just rank them, right? List moves, then sort them on the difference from target and move to the closest one. If target 0, then what do we return? So we want to return the list of moves. Oh, it's the count. If target is 0, return the count of moves. Do you ever use C? No, not really. Okay. So I'll say while not at target. While best distance is greater than 0. Okay. I'll say while best distance is greater than 0, we're going to have some step count. And I'll also do the complexity analysis. Let me come back and do that. So what's the time complexity? There's an unbounded number of steps here, right? Big O, we aren't friends. Hey, the Bean, how's it going? So I think we're bounded by X and Y. We're bounded by X and Y. X and Y is the target destination, right? Yeah. So is it true that I should never need to make more steps than the largest? Because if my knight moves 1 and 2 along different dimensions, am I able to say that Ellie, come here. Kids are not taking a nap. Hey, brother, not great at time complexity, honestly. Most my jobs, I've never had to worry about it yet. Yeah, it's like a big tech thing. You need to know it for big tech. You don't really need to know it for tier 3. And then tier 2 is a mixed bag. Sit on the floor, honey. You're making too much noise and your brother's getting irritated. Okay. So can I just say it's like in the worst case O of n, where n is the larger of x and y. I think that's not true. So let's do a proof by example. So in the case of 0, 1, how many steps? In the case of 0, 1, I can't get there in 1 step. I need to step out over here. I need to do 2 steps. But maybe it's asymptotically the same, because is it always going to be a double limit? I'm going to guess that the answer is yes. I'm not really sure. So I'm going to say that O2n in the worst case goes to O of n. And what about space complexity? I might need to store all of the moves. All the moves that I've taken, which will be driven by the time complexity, and then some multiple of that. I'm going to guess that it's a linear multiple, so that even if I need to store like 4 times that many regions in memory, I'm going to guess it's some constant multiple. So I'm going to say O of n, I think. Thanks for the likes. Do you have any idea on what type of algorithm you have to implement? Yeah, I need to do BFS. And I'm not exactly sure how to use it. Well, the algorithm that I'm proposing, I'm not sure it's right, but it's basically I'm going to calculate the difference between my target coordinate, the distance between my target coordinate and the final target, like the potential destination and the final target. And then I'm going to minimize that. And I'll just repeat until I land there. That's my proposal. I'm not sure that that's really the right thing to do. What's LeetCode? It's a code challenge website. You go there to practice coding challenges to help you land a programming role. Okay, so here I'll just have like moves. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I can move forward once and up twice. I can move forward once and down twice. I can move forward twice and up once. I can move forward twice and down once. And then I can do the reversal. So -2, 1, -2, -1, -1, -2, -1, 2. So I think those are the places where the knight can go. And let's do this Q. So Q, we're going to start this at 0, 0. So while best distance is greater than 0 is maybe not ideal. What are you doing? We do while length of the Q. So the typical way you do BFS is you'll be dequeuing and you'll say, as long as there's a queue there, I'll process it, which is different than the intuition of while the best distance is greater than 0. So this queue approach, I don't know, they might both work, but anyway, we'll do this because it's more idiomatic of BFS. Thanks for the follow. What question is this? This is number 1197, minimum knight moves. What time do I have? 3:30? Okay. We can give this 10 more minutes before we look up a solution. Thank you for the follow. Okay, so I'll say current coordinate is q dot pop 0. So I'll just take whatever's at the top of the queue. Thank you for the follow. So we take whatever's at the top of the queue, and then the question is, well, I guess we can explore, okay, we could explore all of the moves. That's a bad idea though, right? Let's think about the case where my knight moves 1 and 2. So I move 1 and 2. Do I need to continuously resort my queue? Stop. Ella says hi. Hi, Ella. I'm going to keep doing what I originally designed, even though I think it has a flaw in it. But let's just try to get something on the board, and then we'll look up the solution. So my original idea was that we only want to process a move if it's at least like in the direction of the target. And if you think of a quadrant, so 5, 5 from 0, it would be up and to the right. So I don't even want to process moves down and to the left. But I do think that up and to the right, it doesn't need to be a closer target necessarily. So I don't think we want to eliminate. So from target and move to the closest ones. Yeah, you could sort, and it asymptotically wouldn't matter because there's only a fixed number of these 8. Prefer no for now. In theory, we might want to continuously resort, and it would be tolerable because there's a constant number of moves. But I'm going to avoid doing that unless the solution tells me I need to do it. So what I would prefer to do is say, hey, is the destination in the quadrant, in the desired quadrant? And if yes, I'll enqueue all of those. So how do I know you're in the desired quadrant? Well, the target can be up and to the right. Those are the, so I need a vertical direction and a horizontal direction. Okay, so the vertical direction, I'll have my x and y, so y minus my y coordinate. So it's x, y. So here's my, let's do a cur x, cur y. So if y minus cur y, let's call this the up hemisphere. Let's just say should go up. So if you should go up, that's going to be, the target is above you. So y minus current y is greater than 0. Okay, we'll have should go up and should go left. I'll want to guard if at target, return step count. Sit over there. Let's see. Then I need to, so my current x and current y, it's not a step the first time around, right? So we only want to increment the step count at the end, not at the beginning. So we'll step down there. So it's possible to have an answer of 0. Yeah, in example 1, from 0 to there, the output is an integer of 1. Cool. Okay, so I have this step count, this Q. Here's my current X, current Y. If we are at target, the way that we know that we're at the target is Y minus X plus the Y minus the current Y and the X minus the current X is 0. That's how we know we're at the target. We need to call that at target. Okay. So for the target, we return the step count. Otherwise, we figure out if we want to go up and to the left. I'm not sure this is correct because I might want to only go up. It's not possible to only go up. So I'll say that you should go up if you're greater than or equal to 0. Stop. I kind of think that works. So if I know that I should go up, I'll consider any of those set of upward moves. I kind of need to divide these moves into quadrant groups now. All right, let's go ahead and look at the solution. This is my idea, though, is I would say if should go up, explore like associated moves. And then if, so you would enqueue associated moves. If you should go up, and then you would enqueue some different associated moves if you should go left. And you might need to nest those or explore the combinations in 4 combination up and to the left. Yeah, so you might need to interact those. But anyway, that's basically the idea. Let's see if that's anywhere close. So solutions. Slow but intuitive, best for interviews. I'll look at that, and then I'll also look at this one. Let's look at a few of them. Don't touch the chair. Sit over there. That's the 3rd time I've had to tell you to sit in that spot. Don't go anywhere. Thanks for the follow. Okay. It says slow but intuitive, best for interviews. And they say collections.dq. Not a fan. I don't believe we need to use any formula in an actual interview. I had given the following solution for a mock and an actual interview and got through to the next round. Q append 000. Oh, what's this 3rd 0? That's interesting. Q has pop left. So I'm not sure why they're using collections.dq instead of just a list. Let's see about the other ones. This person just uses a list. Okay. Stop, Ellie. Min R, max R. Why would the boundary be +2? How do you prove that? Yeah, I'm not seeing how you can prove that. I mean, trust me, bro, fine. So this is just like a LeetCode memorization thing. If I look at a chessboard, how do I know that the boundary will be +2? I guess that's just a thing to memorize. Bummer. What is the difficulty of this problem? It's supposed to be a medium, but this is one of those mediums where I'm like, I don't really see how, man. Yeah, it's like a trivia problem. Like if you have memorized this +2 boundary, I mean, what you could do is you could say, oh, the knight moves 1 and 2. So it's intuitive that the boundary is an extra move. No, that's not a proof. It's definitely not a proof. So it's just memorization based. Yeah, I don't know. Maybe it's good to have on the kata because you just got to memorize some of this stuff. This time complexity is super crazy. I'm not even sure what this means. Solutions are based on symmetry, meaning x, y will have the same result. So they're not filtering on the should go up, should go left thing. It's literally just like exploring every move. Use pruning to remove unnecessary location. Why not a heap? Oh, I don't know. How would a heap benefit you? Oh, hey, it's the guy who can't get out of Vem. Yeah, that's me. So a plus dx. Dx is going to be delta x. Yeah, so that is like your move. And the time complexity is the absolute value multiple. You're allowed to have a 0x, right? Yeah, this one throws me. You're allowed to have a 0x. The time complexity won't be 0. And it's not as if it's impossible to land on one of these. Like you could go to position 1, 0. Yeah, I really don't like this problem. This strikes me as like a perfect example of a problem that you have to memorize or you're unlikely to solve it. Because I don't think that you're going to derive the proof of the boundary during the interview. I like this problem as a great example of one that is a bad problem. With math induction, you will find a pattern with division, which can replace previous DFS process. Time complexity is O of 1. Yeah, how you get to O of 1 time complexity with an infinite board is beyond me. All right, well, thanks for being here, y'all. And that's going to do it for today's stream. I'm baffled by this problem. Hey, check it out. The link to this problem is in the video description. And I don't know, maybe it's more intuitive to you than me. I see how someone's intuition could tell them, oh, in the worst case, you need to go like one extra move beyond and then come back. I don't think that's a proof. I don't think that's a proof. How do you know you might not need to go 2 moves beyond? Yeah, maybe there's a way to prove that. I'll have to think about it. But it does strike me as one of those that you're going to know it ahead of time or you're not going to know it. So maybe that's a reason that you would include it in the kata so that you can just memorize chessboard night move stuff. Anyway,